Hello everyone. Before I start, I want to just do a quick mic check. If you're able to hear me, please drop a yes in the chat window. Okay. Looks like things are going good. Cool. So, I'll just quickly set the context. Firstly, welcome everyone. Good evening. I know it's a busy weekday and everyone is approaching to the weekend. Again, for folks who are, in different time zones, good afternoon and good morning, depending on the time zone you're in. First, I would like to welcome you all for this webinar, which is arranged by Great Learning. As you can see, the agenda of the webinar is, we are trying to discuss, we're talking about these emerging technologies, right? You must have heard about a lot of these emerging technologies, and we'll try to, delve deep into, how are these disrupting the future of software engineering or the IT landscape, which we know it. Quickly introducing myself, as you can see on the screen, my name is Goutam. I'm in AGM here at Great Learning. I head the tech vertical programs here. We have some programs with, IIT Madras, Triple IT Hyderabad, and also a few other programs which are in the pipeline. I sort of look into these tech vertical programs here at Great Learning. All right, great. So let me just, set the agenda for today's session. So, to start with, right, I'm going to give you a brief about the software engineering landscape. How is it currently? How has it been? And what are the typical kinds of roles and careers which you typically see in a software engineering and IT landscape. Then we are going to delve into how is the future getting disrupted, right? And what are what are these changes, seismic changes which you are seeing. And of course, we are going to talk about specifically on the impact of this emerging technologies, right? I'm sure you must have heard about cloud, blockchain, IoT, AI, big data, etc., right? These are all buzzwords, but let's try to understand how are these impacting software engineering as an industry. And then we'll try to connect all these dots and see what are these various skills that are required, and what are the roles that are in demand right now. And we'll try to also spend some time understanding what are the software engineering programs at Great Learning, and how we at Great Learning, in collaboration with some of the best universities, are trying to address this particular skill demand. And obviously we'll open the floor for some Q&A. We have a team who is moderating the chat windows. They will be sort of curating the questions and then sharing with me, which I will be able to answer during the course of the next 1 hour. All right, so let's get started. Okay, so let me just throw in some key numbers, right? Because numbers sort of stick in your mind, right? So if you look at the Indian IT industry, right, it's around $350 billion, right? That's the size of the industry which you're looking at, and it already employs like 5 to 6 crores directly, and then almost like 20, 10-20 crores indirectly, right? And it's a net value add generator, right? Even if you look at the last year, right, where because of the pandemic, the economy has contracted, right? The IT sector as a sector has actually grown by 4 to 5%, right? And it's also added jobs during this time as well, right? Where jobs have contracted, even the jobs have actually added in the last 1 year. So net, IT industry has been one of the major industry which is booming and also growing with respect to the skills and jobs as well. So you know just to just to check, what are some of the top in demand jobs, right? We looked at LinkedIn, which has done some study, right? Amongst the top 5 jobs which are listed here, the first 4 jobs are software engineering roles. That just clearly talks about the clear demand of software engineering and IT jobs. Okay, so let me just spend some more time understanding what is the lay of the land, right? This is a this is a study and survey by Cut Short. They try to understand what are the salaries which people get at various work experience domains, within the IT industry. You can see that within 10 years people get a scope to earn up to 25 lakhs. And then again, this is a very, I would say, this is still a, it's a not the whole representative sample. If you look at good product companies, entry level engineers get 20 lakhs, right? There are people who at a senior level, they get earn more, they earn easily more than 60 lakhs, and then close to a crore as well, right? So that that talks about one important thing, right? Good skills are always hard to come by, and companies are willing to pay a premium for their skill sets. So, let me again talk about what are the various typical career paths you see within, in IT industry, right? Again, this is not a entire sample. I'm just giving you a representative sample. There are few roles which we have sort of, purposefully left out for, to provide some clarity here. So everyone starts with the software developer or software engineer role, and then you try to move up to a senior software engineer role, right? Or some people call it a tech lead as well, right? Post this particular role, people have a choice, right? You either you want to get into the technical side and build up your technical career, or you want to move to the functional roles, right? So if you wish to move to the technical side, then there's a road to a lead and an architect, right? Where after a senior developer SD, you will become an SD2, SD3, or a team, people call them team leads as well, right? You become a software or a technical architect, right? And then you try to, again, you'll become a principal architect, and then you become a director or VP of engineering. Now, uh, on the other end, right, if you want to move to functional, when I say functional, you're not day in day out coding, but you're focusing on building the entire, you're part of the software development life cycle, but you're focusing more on the project management and the program management aspect of it, and the architecture aspect of it, right? This is where we have like roles such as project managers, people also call them program managers, technical program managers, delivery managers, etc., etc., right? And we also have people who call called roles such as solution architects, right? Who specialize in developing and delivering a particular solution, like say a Salesforce or an ERP or an SAP solution, right? So now just look at these paths in contrast, right? On one side are technical roles, on comparison to functional roles, are definitely the pay is much more higher, but the skill expectation is also much more higher, right? On the other end, functional roles, compared to technical skill set, yes, you get paid lesser, but at overall level, once you go to senior level, the pay sort of normalizes, right? Now the skill sets required for a technical and functional roles are different, and that's why there is a parity in, there's a difference variance in the pay, as you can see. So let me now jump into, right, how's the next decade looking like, right? We're talking about the future of software engineering. So before I talk about the next decade, which are already in 2021, let's talk about what was some of the seismic changes, right, which helped in how the current decade is sort of progressing. So, the first obvious point, right, that there's a rise in internet penetration, right? If you see that there are like more than billion users, right, and just in India, right, through mobile and also broadband, who are able to access internet, right? That's just extended the reach of software applications, right? So that's one of the key factors, right? So if you are as a, if you're building an application in the past, you might be thinking about only having a few thousand users, right? But nowadays, there are like hundreds of companies, right? Not just hundreds, thousands of companies which easily handle a scale of millions of users, right? That's the amount of major change which is sort of fueling the next decade. And the second also second also is that there is an increasing transition to digital, right? Think of it this way, right? You know Now even a pawn shop, you go to a pawn shop, and most of you, if you try cigarettes, firstly I would ask you to stop buying cigarettes. But then if you go to a pawn shop, now you're not carrying change, right? You're just doing the transaction over Paytm, or a phone pay or a Google Pay, right? So the extent of technology, the reach of technology has really gone widespread, right? Even Sabji Wala is using not just Paytm, but they're using Kata book for their digital pay records, right? So there are multiple tech interventions and solutions, digital solutions which have come into place, where you're even seeing a small use case and you're able to digitize that digitize that space. So that is the second important change which you're seeing. So how does this impact each and every company, right? If any company can't call itself a non-tech company anymore, right? Every company has to enable tech within its own company itself, right? So that is essentially the change, right? Now let's take an example of great learning, right? We take advantage of technology, right, to impart quality education at scale, right? We have more than 7 lakh plus learners, right? And we are trying to do that, right? So that's the increase, that's the impact which we are seeing. And again, this point which I would like to emphasize here is that infrastructure is it might look boring, but this is sort of like the backbone, right? If you don't have good bandwidths, if you don't have high performance systems, you wouldn't be able to think about all these solutions which you are using it on a day-to-day basis, right? uh, our mobile phones nowadays have 8 GB rams, right? I think a decade back, having a 2 GB RAM desktop itself used to be a high-end configuration, right? So the accessibility, the cost of these technologies, right, and the surrounding infrastructure has really laid the groundwork for all these changes which you're seeing. And then last but not the least, right, so software applications are not going to be simple nowadays, right? Let's take Netflix for an example, right? You are simultaneously watching Netflix, right? You have an option to watch Netflix on your phone, on your laptop, right, and also on your smart TV, right? You're having multi-platform access, and then because you are handling a large scale, right, the software system itself is going to become very complex, right? It's not going to be a simple monolithic system, it's going to become a distributed system. So that has led to these are some of the key factors which have led to the key changes in how the software engineering landscape is changing. And with respect to that, what is the how is the role of a software professional changing, right? So that is essentially the key message here, that what the past is now deciding what the future of software engineering is going to be. So if you're a software professional who was just focusing on building front end or back end, right, or working on ERP systems, right, it's not going to be the same solution going forward, right? Your ERP system is going to become a cloud based ERP, for example, right? So you need to sort of attune yourself for the next decade which is upon us. So let's now talk about the impact of these emerging technologies, right? So we see software engineering as at the center of everything, because at the end of the day all these technologies are attuned and complementing a software application, right, which is an end product you are using. Firstly, I'm sure you must have heard about big data, right? There's a tons of amount of data which is being generated, right? You can see that as a human population we are generating about 175 zettabytes of data, right? Just to give you a perspective, what is a zettabyte? A zettabyte is around 1 billion terabyte, right? Forget about having a 1 terabyte hard disk, you're talking about 175 billion terabytes of data, right? That's the amount of scale of data which is being generated, right? That's the reason why people keep saying data is the new oil, right? That's the amount, a lot of these data centers from these major companies, you know through these various applications, we are using we are building a lot of we are generating a lot of data. But that generates an immediate challenge. uh, you know where do you store the data, right? I can't use my own servers, right? That's where cloud comes into the picture, right? If you look at it, more than 50% of the data is going to be stored on these public cloud services like AWS or DigitalOcean or uh, GCP, Azure, etc. Right? Again, it's not just for cloud services, and not just for data, right? You're essentially using distributed systems to build servers, everything. You don't need to think about infrastructure, right? You can develop everything at the click of a button without having spending a penny of infrastructure, buying it yourself, right? You're just renting it out, or you're using it as you're paying as you use, right? That's essentially one of the key seismic shifts which has changed. And then but how is this data, where is this data coming from, right? We have IoT, right? IoT essentially are smart devices, right? uh, like your smartphone itself is a smart IoT device, right? It has a lot of sensors and actuators and accelerometers, etc., which capture a lot of amount of data, and then they analyze a lot of things, and then they share that data, right? So we have we creating tons of amounts of data, right? And if you look at it, two-thirds of this data which you're talking about, this 175 zettabytes, is going to be generated by these IoT devices. And mind you, there are going to be around 75 billion IoT devices, right? That is the scale of data which is being generated, and IoT devices are at the core of generating this data. And then talk about AI, right? I'm sure it's everyone knows about AI, understand what exactly AI is, but all this data is fueling us to think about data centric solutions to build that machine intelligence, right? And build some kind of a solutions which can really help the humanity, and then solve some particular problem, right? Let's take one interesting aspect is that 80% of this data which is being generated through this big data technologies, right? 80% of it is unstructured. So for you to make sense, right, you need to really do a lot of text processing, NLP, to understand what exactly is this data, right? Let's take one particular example. Let's say I'm trying to build a driverless car, right? you know Firstly, I need all the data which is required, right? I need to know what's the lay of the land, right? How's the road looking like, right? I need to know what are the area items within my vicinity, right? So the car has to become a smart car, right? So the car is fitted with a lot of IoT devices which generate a lot of data, and then capture a lot of these metrics which you're looking for, right? That generates a huge amount of big data, right? And that data can't be stored within the within the car, or your own system, right? It has to be stored on the cloud, right? Now using that data, right, we need to analyze and then understand what's the next action which you need to do, right? This is where we machine learning engineers, data scientists, right, etc., researchers build these AI models, right? Based on they do like object prediction. Okay, what's in front of me? Okay, shall I speed up or not, right? And then that's how you are actually building a AI based an application of driverless cars, right? I hope this gives you a perspective of how all these technologies work in tandem. They sort of are interdependent. These technologies don't work in silos. And then last but not the least, for the perspective of this particular webinar, blockchain, right? You're generating tons and amounts of data, right? But how do you ensure this data is transparent, right? How do you ensure there's privacy inbuilt into the system, right? Imagine we are as a human population, we are generating huge amount of data. Let's take just for financial transactions, right? What if someone hacks the bank server, and which contains all the transactions, and then modifies whatever information you have, right? There is a data related security challenges, right? And also transparency related challenges, right? So that's where blockchain as a technology perfectly fits in, where let's assume that in this previous example, right, you're talking about a driverless car, right? But your data is your own, your own private data. You don't want it to share with the entire world, right? So imagine, if each car becomes a blockchain based system, that will give you the, the perfect security aspect which you're looking for, and then build the transparency in the system. So if you look at the impact of blockchain, right, we're talking about 10% of global GDP being stored in blockchain, right? So, in a nutshell, right, these are not, some small technologies, right? These are large scale technologies which are building a lot of, impact, and we are already seeing, the fruits of these technologies. Now coming to the last, coming to, the key aspect, right? Okay, fine, these technologies are great. How are these impacting software engineering, right? That's the question which you're trying to address here. So, because of these particular roles, right? Because of these particular technologies, there are a set of roles which have, developed on the horizon of software engineering, right? So, if you are a software engineer who wants to work in a big data ecosystem, right, then there are roles emerge such as big data engineer, big data architects, right, who do data engineering and data architecture, right? If you are software engineering working on cloud, right, you can become a specialized cloud engineer or a cloud architect, right? Similarly for IoT, AI, blockchain, etc. So essentially, the industry, there are like a new technical roles which have developed, in the last few years due to the advent of these, emerging technologies. So I hope that gives you some perspective on, how the career landscape is changing because of these emerging technologies. So let's try to summarize everything, right? So now as a software professional, what should you, look for, right? The technologies which you are going to work in the next decade are going to be leadingly, majorly, focusing on emerging technologies, and these are going to be large scale distributed systems. So for you to, work on these technologies, you need to get abreast with these technologies and understand how software engineering on the in the current landscape is looking like, right? That's where, NASCOM has clearly identified that, there's a demand for, digital talent, right, who have a, a grasp on these skills, right? There's a demand of around 27 lakh skilled professionals, right? And it's not 10 years down the line, it's just few years down the line, right? So this is the seismic shift which you are looking, right? And this is the major skill gap which, every company is trying to address. So, let me just now look at the skills, right? What are the core skills you require to be in a software engineering field, right? The first building block, right? I call it the foundations, right? You need to understand, core software engineering, right? How to build backend, right? How to write logical programming code, right? Which, and build features, build APIs, right? How to work with databases, because that's where you store all the data, right? And you sort of run queries through SQL, NoSQL, query languages, right? And then, front end engineering, right? How does the application interact, with the client at the front end, right? So this is essentially, I'm sure you must have heard about full stack engineering as a concept, right? If you are someone who knows all these three concepts, then you can really kickstart your career as a software engineer. Of course, one thing which I didn't mention but I would like to emphasize here is the importance of data structures and algorithms. If you look at any major company, right, for an entry level software engineer, they test you on your data structures and algorithm skill set, because if you're really proficient in data structures and algorithms, you have a good problem solving ability, which is one of the major skill sets, companies look for. So you start your career as a software engineer, but you want to build on it, right? You want to, you know now focus on senior roles, right? Now, one thing which is clearly evident here is that you need to now build the design and architecture, skill set. You need to understand how to work with distributed systems, because you are by default handling large scale systems, right? So in order for you to scale up, you need to work with distributed systems. You must have heard about Kafka, Cassandra, right? Spark, etc., right? And then you need to have a really good knack on cloud computing systems, because you're not going to build your own infrastructure, right? You're going to use infrastructure which is given to you by these providers, such as AWS, Azure, etc., right? So so for you to work on you know in, for you to be a advanced software engineer, right? These are the advanced skill sets which you need to possess, right? So these the core and advanced skill sets are the key ground principles and skills which everyone needs to focus on, right? And again, there is a spectrum here, right? If you are on the technical end, you might want to go in depth into each and everything, but if you're on the functional end, you might want to understand things at a high level, understanding how these systems work, right? You need not get into in depth coding on a day to day per se. Now this is where then you need to focus on specializations, right? We talked about four key technologies along with cloud, right? I'm saying that cloud should be one of the core advanced skill set, and then you need to then build a specialization on top of that, right? If you're someone who wants to build a specialization in blockchain, that's one path, right? Or in IoT, or in big data, or machine learning, or AI, right? These are the four key specializations which you can think about, right? So this is how we suggest you to sort of plan your career progression, right? Looking at the skills which are required at this stage. I'll just quickly introduce great learning. I'm sure I don't want to spend too much time here. We have been in a tech organization for more than 7 years, focusing on professional upskilling, because that's a tough problem, right? We have more than these numbers keep changing. We have more than 7 lakhs to 8 lakh plus learners, and we have some of the best academic partners, right? Like IIT Madras, Triple IT Hyderabad, Stanford, Purdue, etc. But if I have to quickly tell you what exactly are some of the key USPs of any great learning program, right? Our programs are long duration, right? The reason there's a long duration is because these are deep tech skills, right? These things can't be attained in a day or a month. You need to spend significant time you know to achieve a level of mastery. Secondly, you need to focus on practical learning, right? I wish, think of it this way, right? uh, you need to you need to lose weight, you need to go to the gym, and you need to do the workout, right? Similar thing here, right? These are deep tech skills. You need to you need to really may roll up your sleeve, get your hands dirty, and actually build something. It can be a toy product, but you need to build that to understand the nuances. And then third, which is one of the key factors, is we try to bring in and loop in some of the best universities, right? We have IIT Madras, we have Triple IT Hyderabad, Stanford, as I mentioned earlier, right? We try to bring in the academic excellence of these top colleges through our programs, and make our learners access to these some of these best faculty out there. And last but not the least, we engage a lot of industry experts as part of our course delivery, because at the end of the day, these are you're trying to be industry ready. So you need to understand the practical nuances which a practitioner faces on a day-to-day basis. That's the whole reason why we bring in industry experts who work on these technologies to be part of the course delivery. So that's in a nutshell, how any great learning program is designed. So now I'm going to spend some time explaining. We've sort of explored what are the skills which one needs to build upon, right? And I'm trying to sort of map that with the kind of programs which you have here. So firstly, for someone who's at a early career, right, who's looking for entry level careers such as software developer, full stack developer, front end developer, right? These kind, which are the core skills. You need to be good at backend engineering, databases, and front end engineering. So for such folks, we have a program called certificate program in software development with from Triple IT Hyderabad. This is a 4-month online program. So if you're interested to know more about the program, you can sort of check this link, and also call this number, and our admissions team will help you explain more details about this program. So if you're focusing more on the data and AI specialization, right? Then you need to have, build the core skill sets. You also need to, have a, knowledge of these advanced skill sets of design and architecture, distributed systems, cloud computing, and then, build the specialization on, data and ML engineering. So for this particular career path, we have a, postgraduate certificate in software engineering for data science. Now this is a 8-month program with Triple IT Hyderabad, where it's a blended program where, there's an online classes component as well, and you also get to interact with Triple IT Hyderabad faculty at the Triple IT Hyderabad campus. That's an interesting proposition. And also, this program also gives you an alumni status from, the outreach division of Triple IT Hyderabad. So if you are interested in this particular program, do check out this URL, which you can see on the screen. And last but not the least, if you're interested, in a specialization in IoT and blockchain, then we have a program with IIT Madras, which is an advanced certification in software engineering for cloud, blockchain, and IoT. Now this is a 9 months online program, and if you're interested, you can do check out the URL. So I will just spend some time now. Okay, so we have talked about what the various skill sets. Where do you stand, right? So if you're someone who's in the technical side of things, right? If you're a software engineer or an architect, right? Now you need to you know uh, you need to sort of build yourselves to be an engineer and architect, right, who's specialized in these technologies. Similarly, if you're a functional person, right, who is working as a project manager, a program manager, or a solution architect, right, you have an option now to transition yourself into a solution architect for blockchain or IoT or big data or AIML, right? So these are the various career transitions which you can foresee through these particular programs. I understand that career transition is not easy. That's where Great Learning provides a GL Accelerate, which is a career support program, right? Where we have types with more than 400 leading organizations, who hire our alumni through who take our programs, and this is an exclusive career support program only for Great Learning alumni. And you can see that there are more than 7,000 successful career transitions which have happened till date, and this number keeps on growing. So just to give you a perspective on the kind of learners which we have for our software engineering programs, yes, you can see that it's majorly more than three-fourth are folks who are already in the IT technology domain who are looking to upskill in these emerging technologies, right? And then we also have folks from other domains as well who are who enroll into our programs. And if you look at the work experience split as well, it's evenly split. More than around 60% is more than 8+ years. We also have around 20% who are 0 to 5 years, who are at a freshers, early career professionals who take a software engineering programs. And just to give you a glimpse, again, this is just a representative sample of the kind of companies our learners come from. Again, just an additional list of companies which you can see for your own reading. So now, I hope that has given you some perspective, right? To quickly summarize, we looked at how software engineering as a career is changing, and how it's being disrupted by these emerging technologies, and what are the skills, requirement, how is it changing, right? And we also try to, explain what kind of specializations and career paths you can choose based on, what roles you are in currently, right? So if you are interested in any of these programs, again, do reach out to these links, and then our admissions team will help you understand more details about the program, and you can enroll for any future batches which are in the horizon. So now I see that there are a lot of questions, so I will quickly address these questions. Okay, so there's a question about what's the difference between data analytics and big data, right? Okay, so this is an interesting question, right? Now, big data essentially is that you're handling a huge amount of data, right? So you can't just have one simple server and then store everything in that one particular database, right? You need to scale your database to handle large amounts of data, right? So in order to do that, there's a concept called distributed systems where you use the NoSQL kind of a databases where you can do horizontal scaling or vertical scaling of your databases so that you can handle these large amounts of data, right? That's where big data comes into perspective. So now what is data analytics? You have all this data, but you need to make sense of this data, right? What is this data telling us, right? That's essentially data analytics. To give you a simple example, right? Let's take YouTube, right? YouTube is capturing a lot of our data, right? They're capturing what all videos we see, right? They're also capturing what videos we watch for what duration, right? And what kind of genre of videos we watch, right? They capture all this information, right? This is raw data. But a data analyst, right, it does exploratory data analysis, right, and take some insights. Okay, for example, we'll take you as a user, and then we'll see that on an average you spend not more than 5 to 10 minutes on a video, right? That's an insight, right? How is this insight useful? This insight is useful for YouTube to figure out what video to suggest to you the next time. Because if you're not watching something more than 10 minutes, I don't want to recommend you which is a video which is for a 1 hour duration, right? So these are this is where you're trying to make sense of data, generate some insights, and then build some predictive models through AI ML techniques, right? And then help the user at the end of the day. So, some people also asked about the career path for DevOps engineer and the cloud engineer. So, yeah, DevOps engineer, previously, it used to be a pure admin job, right? But, you know, DevOps as a concept has kicked in, and then you're talking about agile development, right? So that's where the role of a DevOps engineer has really transformed the industry, and now where development is itself happening on cloud, right? There's a huge DevOps on the cloud is becoming more pertinent, and that's where you see roles such as cloud DevOps engineers, who focus on helping the developers build fast, right? So that's essentially what at a high level what DevOps engineer does. What's the difference between a data scientist and a data analyst? Can you shed some light on this, Liz? Okay, so I'll just take back the previous example which I talked about, the YouTube thing, right? A data analyst skill set is a subset of a data scientist skill set, right? A data analyst, at the end of the day, you know uh, crunches this data and then throws out some insights. Hey, you know what, my average viewing time is this, right? People watch these kind of genre of videos more, people watch at this time of the day, right? These are insights, right? But how do you use these insights to build some predictive, and build some intelligence into the system, right? That's where data science comes in, right? So you have a data scientist who will use these insights and as inputs and then build a prediction model, right? In this case, let's say he's building a recommendation system, right? So this is a an ML based application which the data scientist is building, which we as end users utilize, right? So that's essentially the difference between a data analyst and a data scientist. So a data analyst, I would say, is one of the entry parts into data science, and then then they can build up the skills which are essentially machine learning techniques and deep learning techniques, and then try to become a data scientist. Okay, the question: for someone who starts his career, is it better to change technological areas and find the one which likes him the most, or stay at specific role and become perfect at it? Uh, that's a really good question. You know, uh, I sort of believe in this, methodology called, you know, uh, there's a T skill set, right? Essentially, while you dabble on multiple technologies, yeah, try to, focus on one particular technology, which is your core strength, right? You can't, while you try to perfect that particular skill set, yeah, you can't just ignore other technologies because, when I explained you about these technologies, right, there's a lot of interdependence, right? When I talked about this driverless cars experience, example, right, you can't just learn IoT. You need to understand how to, how does this integrate, and how does the data get stored on cloud, right? And also, how do you build a machine learning model which will predict what to do, what the car has to do next. So there's a lot of interplay between these technologies as well. So you can't just remain siloed. You also need to understand the linkages between these technologies. So while you specialize in one area, you need to also sort of understand the perspective of other technologies as well, because there's a huge interplay between these technologies. Okay, that's a question, right? Which specialization skill has highest demand in market? Uh, I don't want to, take any sides here per se. I see that there's good amount of demand for even, cloud specialization, or data specialization, or even, IoT and blockchain specialization, right? You know, all these domains are just, growing at a scale which we are not, which we are not, not able to, comprehend, right? You know, Now every the software development is becoming cloud dependent now, right? You're not talking about on-premise software development, right? If you're looking at, for example, if more than 60% of companies IT spends is on cloud services, you need to understand the impact of cloud services, right? And if you're talking about 175 zettabytes of data, every company is sitting on a lot of amount of data, and they're not clear on what to do with that data, right? They're not able to build a proper big data ecosystem to manage the data, and then build some intelligence products around it. So everyone is building their own teams within these technologies. So I don't like to specifically favor one over other. Okay, so you have a basic knowledge in MySQL. What kind of courses can you suggest? So if you have understanding of how data works, right, then you can sort of choose a data engineering track, right? Maybe I would suggest the software engineering for data science program, where we cover data engineering and ML engineering. Maybe that is something which you can explore. But what I would like to suggest here is that everyone who is in the software engineering domain, right, needs to understand the SDLC, right, the software development life cycle, right, how software systems work in general, right? Those are some of the key skill sets which are required. So while you might be specialized in one area, it's really important for you to understand how the systems work at a whole. So you want to become a blockchain software developer, but most of the companies are not working on this technology. So this is specifically pertinent to India, I would say. Okay, there are two things here. Okay, uh, there is no specific, while there's a term called blockchain developer, right, a designation. Not many companies sort of advertise or do job postings specifically looking for a blockchain developer, because at the end of the day, when you're an entry level blockchain developer, right, you're just trying to build smart contracts, right? That's the one key skill set you're looking for. But a blockchain developer also needs to understand how to work with software systems. So what most of the companies are doing is that they are taking general software engineers and teaching them the blockchain skill sets, and the designation will still be blockchain software engineers, okay, but they'll be working on blockchain systems. Okay, so this is pertinent to India. But if you look at globally, I would say India is 1 2 years behind with the implementation of blockchain, I would say, right? 2 years back, a lot of pilot projects for blockchain have kicked up, and those projects have become mainstream now, right? Let's take Walmart for an example, right? Walmart's entire vendor supply chain is stored on blockchain now, right? Yeah, I think just yesterday news has come where SBI is going to use JP Morgan's blockchain based system for its entire transactions, right? So these kind of I would say that the beginning is just there for blockchain, and I think by the end of this year or early next year, the demand for blockchain professionals is really going to skyrocket. uh, okay, this is the last question, I would say. How does this technology impact an electrical engineer, right? Again, I don't know what stage you're, if you're a fresher, right? And the good part about software engineering is that while they would appreciate someone who did so computer science engineering, right? They this is one of the most meritocratic industries which we have seen, right? Skills matter, right? If you can prove that you can, you have the skills, right? There are multiple ways you can prove that, right? If you are trying to be a software developer, right? You don't, while courses and certifications definitely help, right, from these top institutes, right? What this what great learning any of these great learning programs help you are trying to build projects, right? This is like your portfolio. If you're a photographer, right, you ask, if you're looking for a photographer, you ask for a portfolio, right? You can't just look at him, okay, he has a camera, let's hire him, right? Similarly, if you're a software engineer and if you want to move towards software development, right, you can do a lot of projects on the side and you don't need to really have a working experience to build something, right? You can actually build a take a hobby project of building a full stack web application, right? Let's say you try to build your own Swiggy, or you try to build your own Flipkart, right, e-commerce application as a side project, and showcase that on your GitHub profile, right? That is going to be your portfolio, right? So companies will appreciate folks who show skills, rather than just talk, right? So so that's one of the biggest plus point for anyone who's in the IT industry. So it's a very meritocratic. You prove your skills, they will sort of take you with open arms. Okay, there are a few more questions. So what about big data? I think we are already in the big data world, right? We are already generating huge amounts of data, and we are already seeing a lot of applications of big data, right? A YouTube recommendation algorithm you're already getting exposed to, a Netflix recommendation algorithm you're already getting exposed to. So big data has already made strides and we're already seeing the fruits of it. So there's a good question, right? While you want to specialize in AI and data science, having a knowledge in all fields would be great. That's exactly the point which I'm trying to drive, right? You can't just build, let's say, the example which you talked about before, right, which is the driverless cars. You can't just about think about building a model, right? You need to understand how these IoT devices work, right? You need to understand how these IoT devices are capturing the data, right? And you need to understand how this data is being stored on the cloud, right? For you to build the model, you need to extract that data on the cloud, right? So you need to understand how you know uh, these technologies work together to build a solution, right? So to simply, in simple terms, a solution, right, it's not just a pure AI based solution or a pure cloud based solution. There are a lot of these technologies which come into play to build a solution which which we're trying to you know which is going to help the humanity or businesses. So you need to have a perspective of all these technologies. uh, okay, I think you're in final year of mechanical. How can you build a career in IT field, right? I think I sort of addressed this question. It's a very meritocratic industry, where you can build everything from scratch. That's the good part about IT engineering. In fact, the other side of the story is that there are computer science engineering students who know zilch about programming, who do not have any fundamentals of programming, right? That's sort of the irony of our education system as well. That's where most of the IT training institutes, etc., have sort of popped up, and they're trying to address this gap. Okay, there's one more question. Currently, you're pursuing data science PGP. Can you provide some suggestions? Right now, look, if you're at the early stages of your data science specialization, right, and you're targeting roles such as a data analyst and data scientist, I would suggest first build your career on that. Okay, so just try to stay where you are and focus on building those skill sets. Okay, but over time, right, when you want to move to senior levels within a data science team, right, you need to understand the software engineering aspect of data science as well, right, where big data, the big data engineering comes into play, ML engineering comes into play. How do you deploy these ML models at scale, right? So that's the software engineering aspect of data science, right? So if you're interested in that, maybe you can take up the software engineering for data science program, which from IIIT Hyderabad. But I would suggest first complete the current PGP program which you have, and then get into a data science team either as a data analyst role or a data scientist role, and then you can consider this, the software engineering for data science program. Okay, looks like we don't have many more questions, and I think we are also sort of approaching the end. So I'll just wait for 2 more minutes if there are any last questions. Otherwise, I hope you have taken some key takeaways from this session. I'll just leave at this particular slide again. So this essentially is what we're talking about in the last 45 minutes to 50 minutes, right? For you to be in the software engineering domain, right, you need to first focus on building the core skill sets, which is core programming, backend development, front end development, databases, which essentially is full stack engineering, right? Once you build the skill set, then you need to focus on for advanced roles, right, the senior roles, right? You need to understand how to work with distributed systems. You need to understand design patterns, various architecture patterns, right, like microservices, etc., right? And you need to understand how to work with cloud, because that's we are talking about cloud native development. So once you build this core and advanced skill sets, right, that's when you can look at all these specializations. And whether you want to be a ML engineer or a big data engineer or an IoT architect or a blockchain architect, these are all different paths you can explore once you build these core engineering skill sets. Okay, looks like we are I think there are no more questions. So thanks everyone. Thanks for your time, and I hope you had some key takeaways from this session. So if you're interested in any of our programs at Great Learning, either the IIT Madras program or the IIIT Hyderabad program, do reach out to the admissions office, and then they'll guide you on the next steps. Right? They'll explain you exactly how this program is going to help you, and what kind of roles you can expect. They'll also talk about how our career support works and what kind of careers you can look forward to post completion of these programs. Okay, I'll take one last question. Can you please tell the best language for IoT? Mm, Again, there's no language per se. Here you can pick any language that you want. Take Python for example, and then try to implement IoT based applications on Python. So Python is one of the easiest language to learn, and you can implement all your IoT applications on Python, and it's fairly easy. So and for you to work on IoT based systems, you have IoT Core with AWS, or you have Google Firebase, where a lot of these IoT services are sort of inbuilt, where you can build these IoT data pipelines. So you can use those services as well. Okay. On that note, thanks everyone. I hope the session has been fruitful, and you have some key takeaways. So have a good day, and take care.